you guys have all done this. What you guys did last year in geometry, and I think it was section 10.7, you guys wrote the equation of a circle. You did that, where it was x minus h, y minus k, where h and k was the center. You guys did that last year. Okay. What we did with that was, if the center of the circle is at 2, 3, and the radius is 5, you would write it out as x minus 2 quantity squared plus y plus z quantity squared equals 5 squared, which is 25. And that's all you did. That's really it. It was really easy. Okay? There wasn't anything craziness to it at all. And basically today, what we're going to do is the same thing. But like I said yesterday, where will our centers be located for the course of these first few days? At 0, 0. So if my center is going to be located at 0, 0, that means my h and k will be at 0, 0, which means my formula for the circles for today will be and that's going to be our equation for today. It is going to be really, 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 really easy. Do you guys know the specific definition of a circle? Thanks. Correct. It's a set of a circle is defined as a set of points all equidistant from the center. So that's how you generate a circle. I was just wondering if you did that. So what happens then is that we're going to have circles at the origin. See how close that was? Not bad. Hey, not bad for quick counting. So if I have a circle that has a radius of 3, the equation would be something. Very good. This would be x squared plus y squared equals 3 squared, which is if you want to rewrite it as x squared plus y squared equals 9, go for it. If you want to write it like that, fine. Okay with that. All right. Circles are going to be really, really, really easy. That's another reason why I thought it'd be perfect for working with circles today, because it's a Friday and everybody's brains are done.
I'm brain dead.
Yes. Okay. I'm sorry. Oh no. How do I graph this circle? I don't know. Oh no. I don't know what to do. So I have a circle. Y squared equals 25 minus x squared. Which means, in standard form of a circle, the equation would be oh no, what's my radius? Oh, the pen did that. No, you jinxed me. Lofthouse used to do that a lot. Last year, Lofthouse traveled a lot, so he would come to my room for one of the class periods, and he had a tendency of taking that and just putting it in his pocket and walking away. And I'd be left with no pens, and I would walk into his classroom away.
There's 4 pens sitting on it.
Pretty much, that's usually what happened. So this is really tough, guys. I really, really, really hope that you can follow along with this. This is one of the most complicated graphing systems that you will do. Don't scoff at that. I know. It's really, it's okay. It's okay. It's okay. Okay. Again, when you're graphing, hey guys, when you're graphing circles, it literally is just 4 points. Just try to make a circle. Hey, what if your radius was 2√3? Now, this does happen. This does happen. Let's say it's an x squared, y squared equals 12. Now, that 12 is the r squared. Now, that means that r is the square root of 12, which is, we all know as 2√3. Now, here's what happens. When you go to graph something that has a radical, I want you to think of root 12 is between what two perfect squares? 9 and 16, right? Root 12 is between the square root of 9 and the square root of 16. Which one is it closer to? 9. So if I'm graphing that, I would just put my dot closer to the 3 than I would the 9. That's all. I just wanted to show you that, okay? It still works. You're just guesstimating when you're plotting something. It's not like graphic. Makes, yeah. So far, so good? Okay. Well, let's make this just ever so complicated. Why not? The point 1, 4 is on a circle whose center is at the origin. Write the standard form of the equation. Exactly. Oh. Very good, very good. So it says that the ordered pair 1, 4 is a point on the circle, which then allows us to figure out what the radius is. Because change in x, change in y gives you the Pythagorean radius. So, nope. Now, in this case, what's your radius going to be? So, if the radius is going to be 2, how can you have a radius that happens to be shorter than the side length of the right triangle? Last time I checked, quick, what's 4 squared plus 1 squared? Wrong! 4 squared plus 1 squared. I just probably put it around this spot. I don't know. I'm just yelling 3. She's like, it's 3. I'm like, no, it's not. So remember, when you're writing up, if I have to write the equation of the circle into that standard form, remember the equation is going to be x squared plus y squared is r squared. What's r squared in this case? It's 17 in this case, yeah. See, so this would just, my answer would just be, bless you, bless you. That's what it will look like. All right. Super, super, super easy. Once we remember that 1 squared plus 4 squared is 17. Sorry I put you on the spot, but that was really funny. I'm a cruel human being. All right. Let's write the equation of the line that's tangent to the circle at a specific point. Ah, exactly. What does tangent mean? So, exactly, touches it once. So, I'll give you that. Anyway, when we're talking about this thing, write the equation of the line that is tangent to the circle. Well, when circles, it's close enough. If I'm tangent at the point 2, 3, what happens when you are tangent to a circle? You touch the circle at one spot, correct? What are you to the radius? You're perpendicular to the radius. Okay? Now, what I want you to think of here, well, can you find the slope of the radius? Now think about where you're starting at. Where are you starting your circle, your radius at? 0, 0. Slope, if you recall, is change in y over change in x. It's your rise over run. Very good. Now in this case, my change in y over change in x, since I'm starting my y value, I had to go up 3 over 2. So what's my slope? So the radius has a slope equal to 3 over 2. You all right with that? Now it goes back to what you remember, or if you remember, from Algebra 1. Writing the equation of a line that is perpendicular to a specific point. Reciprocals, right there. So what happens here is that you now have a slope and a point, and you need to write it perpendicular. Now, when you write the equation of a line that's perpendicular, remember, perpendicular slopes are opposite reciprocals. Change the sign, flip the fraction. Okay? And then we just use, our perpendicular slope in this case would be, and I want to write it through the point of 2, 3 then. Do you guys remember this little thing called point slope form? That's what my geometry class was using yesterday. So point slope form is the working version. Hey, you know what that is? Point slope form is a hidden version of A, H, and K for lines.
I'm here.
So you get Y. And then it's a matter of whenever you write equations of lines from you guys, make sure you put them in the slope-intercept form. So you're just going to distribute and solve for y. You distribute out there, you're going to get what? Negative 2/3 x plus 4/3. And then when I have to move my 3 over, I'm going to move 3 over. Instead of just add 3, I'm going to add 9/3. Because I'm using my fractions right away. But remember, if you use the fraction bar in your calculator, it'll do the same thing for you. So you're going to get y equals negative 2/3 x plus 13/3. And that would be the equation of the line that is tangent to the circle from the specific point. That's the one that takes the longest to do. No. Oh, that was my geometry class. Do that one. Same thing. Write the equation of the line that is perpendicular. I'm sorry. Write the equation of the line that is tangent to the circle at 2, 1. Write the equation of the line that is tangent to the circle at the point 2, 1. Not really. I mean, it's because if you start thinking about it, it's just a process. It's just a procedure. Are you still talking?
Somehow.
Yeah, I got bored with it though.
Sounds like marriage.
Anyway, so your slope here was 1/2. In this case, it's just also dumb luck with the 5 for the circle radius and the wider is the same. It's just dumb luck. Now, this will get more complicated, believe it or not, once you start putting circles not centered at the origin. You might actually have to find the slope then. So what stinks is that I used to have this Powerball simulator. And I won the $1 million once, but it took me 62,000 years to win $1 million. Actually, I'm sorry, I won it twice. So, but after 62,000 years, I still hadn't won the Powerball. Yeah, to get the Powerball. Let's see. Do I have more problems? I think this is it, and I think it might not be all of them. That works. Oh, really? Which means it's not going to line up with this. Did it stop at 75? Count